Welcome to G Fun Facts Online. Imagine a lost continent, complete with towering mountain ranges, vast plains, and ancient river systems. Now imagine it's been hidden from human eyes for millions of years, locked away beneath a sheet of ice up to 3 miles thick. This isn't a fantasy world. It's the continent of Antarctica, and thanks to incredible technology, we are finally piercing the veil of ice to reveal the staggering world beneath. For centuries, Antarctica was just a vast, white emptiness on the map. Today, we know that the true story, the subglacial story, is one that shapes our planet's past, present, and future. To understand this hidden world, you first need to know that Antarctica isn't one landmass, but two, separated by the mighty Transantarctic Mountains. First, you have East Antarctica. This is the ancient heart of the continent, a geological shield of rock over 3 billion years old. It's a place of immense stability, covered by the thickest ice on the planet. But stable doesn't mean flat. Buried deep in the center of this ancient shield is one of Antarctica's greatest mysteries, the Gemburtsev subglacial mountains. These are mountains as vast as the European Alps, with peaks reaching nearly 3,000 meters high, yet they are completely submerged in ice. Their existence was a puzzle for decades. Why would a massive, young-looking mountain range be sitting in the middle of an ancient, stable craton? It defied geology. The answer, pieced together by a massive international effort, is incredible. The Gemburtsevs first formed 1 billion years ago, then eroded away over eons, but a deep, cold root of rock remained beneath them. About 100 million years ago, as the supercontinent Gondwana was breaking apart, tectonic forces rejuvenated this root, pushing the mountains back up. Then, around 34 million years ago, the climate plunged, and the East Antarctic ice sheet formed with astonishing speed, effectively flash freezing this pristine alpine landscape, preserving it perfectly beneath the ice. Beyond the Gemburtsevs, East Antarctica also hides enormous subglacial basins, like the Wilkes Basin, which are depressions in the bedrock so deep they lie far below sea level. This makes the ice resting on them vulnerable to melting from warm ocean water. Now, cross the Transantarctic Mountains, and you enter a completely different world, West Antarctica. This region is a geologically young, dynamic, and volatile place. It's dominated by the West Antarctic Rift System, a huge valley where the Earth's crust is being stretched thin, creating deep troughs and chains of volcanoes. In fact, there are numerous active subglacial volcanoes here. These volcanoes act like hidden hot plates, melting the base of the ice sheet and creating vast amounts of water that can lubricate the flow of glaciers. Much of the bedrock in West Antarctica is below sea level, which makes its ice sheet inherently less stable than its eastern counterpart. This geological personality difference is key to understanding how Antarctica is responding to climate change. But before the ice, there were rivers. One of the most breathtaking recent discoveries is the mapping of vast ancient river systems hidden beneath the ice sheet. Using ice-penetrating radar, scientists have found the remnants of a huge coastal plain stretching for thousands of kilometers. This landscape was carved by large rivers between 80 and 34 million years ago, a time when Antarctica was green and temperate. These remarkably preserved river valleys offer a stunning glimpse into a warmer, wetter past. But they aren't just historical relics. The flat, ancient riverbeds appear to act as a break on the ice flowing over them, while deeper troughs carved by glaciers act as express lanes, channeling the fastest-flowing ice streams out to sea. This pre-glacial landscape is actively controlling the ice sheet's behavior today. So how on earth do we see all of this? Peering through miles of solid ice is a monumental challenge. The workhorse of subglacial exploration is ice-penetrating radar. By sending radio waves down from an aircraft, scientists can map the world below. The waves bounce off the bedrock, creating a detailed 3D map of the hidden topography. The strength of the returning signal can even tell them if the ground is hard rock, soft sediment, or liquid water. In fact, unusually strong and flat reflections were the first clues that led to one of Antarctica's most profound discoveries: subglacial lakes. While radar gives us the big picture, the only way to get a direct sample is by drilling. This is an incredibly difficult task. Using custom-designed hot water drills, teams must melt a hole through kilometers of ice, all while ensuring the process is perfectly sterile to avoid contaminating these pristine, isolated environments. And what we've found in these environments has rewritten the rules for life itself. For millions of years, hundreds of lakes have existed in total darkness, under crushing pressure, sealed off from the outside world. The logical assumption was that they would be sterile. That assumption was spectacularly wrong. In 2013, a project called WISSARD successfully drilled into Lake Whillans in West Antarctica. When they analyzed the water samples, they found they were teeming with microbes. A vibrant ecosystem was thriving 800 meters beneath the ice. A few years later, the SALSA project drilled into another nearby lake, Lake Mercer. They too found a thriving microbial community, but they also found something else, something mind-blowing: the preserved carcasses of tiny animals, including crustaceans and tardigrades, also known as water bears. This suggests that the subglacial environment might have once supported more complex life, which was then trapped and preserved. So how do these organisms survive? Without sunlight, photosynthesis is impossible. The answer is chemosynthesis. These microbes are extremophiles, organisms that thrive in the most hostile conditions imaginable. Many of them are lithotrophs, which literally means rock eaters. They derive their energy from the chemical breakdown of minerals in the bedrock below. They are living proof that life doesn't always need the sun. This discovery is one of the most exciting in modern biology. It demonstrates the sheer tenacity of life and radically expands the known boundaries of where it can exist. And it has thrilling implications for the search for life beyond Earth. The icy moons of our solar system, like Jupiter's moon Europa or Saturn's moon Enceladus, are thought to have liquid water oceans hidden beneath their frozen surfaces. The subglacial lakes of Antarctica are our closest analog to these alien worlds. If life can thrive by eating rocks in the dark under Antarctica's ice, perhaps it can do the same in the hidden oceans of other worlds. The relationship between Antarctica's hidden geology and the ice above is a dynamic dance. The geology controls the ice, and the ice shapes the geology. The Gamburtsev Mountains anchored the formation of the ice sheet. The deep basins create areas of potential instability. The ancient riverbeds regulate the speed of glaciers, and the subglacial water, generated by pressure and geothermal heat from volcanoes, acts as a lubricant, allowing ice streams to slide faster towards the ocean. Understanding this intricate connection is critical. The West Antarctic ice sheet, with its volcanic activity and subsea level bedrock, is particularly vulnerable. A small amount of warming can significantly impact its stability, with major consequences for global sea level rise. By incorporating the details of this hidden world into our climate models, we can better predict our planet's future. The exploration of subglacial Antarctica is one of the last great frontiers of discovery on Earth. We have only just begun to scratch the surface of this mysterious world. With every new survey, we reveal more of its secrets: new mountain ranges, new river systems, and new forms of life. The ancient landscapes, locked away for 34 million years, are finally emerging from the shadows, giving us a clearer vision of our planet's deep past and a more urgent understanding of its future. Thank you for listening to G Fun Facts Online.